Okay, let's do the Google Play Store data analysis app. We start by looking at this goofy file. It's the data file, actually. It's a CSV file, comma separated data file. And it's the first row contains the column titles, app, category, rating, reviews. And then every subsequent row has those values. Like this one here, uh, the app is, well, actually, let's do this one right here. The app is Photo Editor and Candy, Camera and Grid, and Scrapbook. That's the name. It's in the category of art and design. Its rating is 4.1, and so on. Okay, and then we have a lot of these rows, as in over 10,000 of them. Okay, the app itself is right here, and here's what it does. It actually analyzes or does some basic analysis, or lets us explore really that data. So we can have a bunch of commands, and we can go ahead and list these commands. Woohoo! We can also quit. Great. But what we can do is print the categories. Okay. And here, what this is doing is it's going through this row by row, and it's looking at the categories, so like art and design, and it's converting it into this art and design here, which is lowercase and missing those underscores, making them spaces. It looks at every line, so it sees art and design here, but it doesn't include it because it already did. So it goes through every line, and when it gets to a new category, it goes ahead and prints out just those categories. Okay. Once you have a category, let's say like where we have here, how about auto and vehicles? Okay, you can get the best and the worst in that category. So the best autos is this app, 4.9, and tons of reviews. And the worst in the category of autos is this one. Okay, and so the way we're saying is best is highest rating, and if there's a tie, we'll do the one with the most reviews because that's probably the most reliable. Okay. Uh, and you might have noticed, by the way, in categories, there's this 1.9. That's because there's actually a row that has a category of 1.9. So we call that uh, unclean data. The data hasn't been cleaned exactly. Not our problem. We'll just do the best with the data we have. Okay, so that's essentially it. That's what the app does. Let's go ahead and see how it does it. Also, I'm moving rather briskly. That's okay. You can always go online and look at the app itself. I encourage you to do that. And of course, you can go to office hours and talk to teaching assistants who will help you further. Cool. Okay, so here's our app, and at a top level, what do? We just list the commands, and we get your command. Okay, if you want to quit, we quit. If you want to list the categories, we do that. Otherwise, you want the best, we'll do that, or the worst, we'll do that, or we'll say we don't know what you just asked us to do. This could be called a command loop or dispatcher, command dispatcher. It just basically says over and over again, get the command and do it. Pretty straightforward. Okay, so let's do get categories. Okay, so here it is. Here's get categories. We read in the file using read file. You don't have to know how read file works. You just have to be able to use it. So we read in this data as one big string, and that's our contents. Okay, now we want to pull the categories out of these contents. So we split lines, so we're getting at the data one line at a time. Okay, and then we do this line right here is a little weird. What we do to begin with is we split on commas, which we've already seen what that does. The reason we split on commas is each line, this is a line right here, and each line is comma separated data. By splitting on commas, we get each individual field. And then this does what's called a parallel assignment or multiple assignment. And let's actually look at that real fast, okay? So what you can do in Python is I can say x, y, z, oops, z equals 1, 2, 3. Now x is 1, y is 2, and z is 3. That's called parallel assignment. Okay, and so here the line dot split actually returns the in this case what I think it's 13 values, and we can assign them into variables: app, category, rating, and so on. So after this line, all these variables hold just that column. Now I should note they're all strings. Even if it's a numeric value, it's the string of that value at this point. Cool. Now we have categories, and we said a category like art and design, we want to take to lowercase, that's what this does, and convert those underscores into spaces. Beautiful. Now when we have a category, we say, have we seen it before? We have this string that's all the categories we've seen. If we haven't, add it to that string and put a new line because it's a multi-line string. When we're done, return the categories. That's it. Okay. So now the heavy lifting is done by print best or print worst in category. Let's look at print best in category. Okay, so here it is, best in category. You get the category you want. You can abbreviate because we'll just, if you say like auto and the actual full category, right, was auto, what was it? It was autos and auto and vehicles. But the word auto matches that part, right? So you can just say any substring that will appear in that string. Okay, cool. So now, what do we want to do? We want to find the best one. We want to go through all of them. We want to get the rating of each one. And if the rating is bigger than the one we've seen so far, that becomes the new best one. Also, if the rating ties the best one so far, but has more reviews, it's also the best one. Okay? So we have the best one we've seen, which initially the best rating would be 0, right? We haven't seen anything. The best app is the app with the best rating. Initially, we don't have one. We go through every line. The 1 colon lets us skip the first line, okay? Because the first line, as you recall, was this. It was the headers. It's not actually an app, okay? And then for each line, we go ahead and we get the category out of the line. The rating, we call get clean rating because the rating isn't necessarily clean. It's a string to begin with, so we have to convert it to a float. But sometimes there's the string NaN, which means not a number. That's just dirty data. It probably shouldn't be there. And we'll just put a rating smack in the middle of a 2.5, which essentially gets us to ignore this because we're going after the largest and the smallest. Is this a beautiful way to handle this? No, but it's sufficient for our purposes. So really modestly cleaning the data to not only convert it into a float, but to get rid of those NaNs. As for the reviews, the number of reviews, same exact deal. When we clean the reviews, some of those actually have an M in them, which stands for million. So instead of having like 634, which would be 634 reviews, there's actually one that says 3.0 M, and they mean 3 million. So what we do is we see that it ends with an M, and so we do colon up to -1, up to and not including that M. That would be this part of the number. Turn that into a float, multiply it by a million, and then pull out the integer value of that. Cool. In any case, after we've cleaned up this up, we do exactly what I said. If the target category is in the category, so if auto is in auto and vehicles, that means we want to actually consider this one. If it's not, like if we're looking at art and design and we're looking for auto, we just ignore it. And then if we got a better rating or the same rating but more reviews, that becomes our best one. When we're done, we simply report, hey, the best one in the category you asked is this app with this rating and that number of reviews. And of course, worst is similar, but adapted. So really, that's that.